Hello and welcome to SudoKanard. We're here to solve this pointing digit Sudoku by Indian author Akash Doulani. This is a puzzle from Akash's latest Sudoku book, which is titled Sudoku Exotica Volume 2. In those books, Akash uses rare variants of Sudoku, and pointing digits is definitely not a variant that you see so often. And his puzzles are very good practice. His puzzles are very good practice puzzles for online contests and competitions in general. So I will suggest that you check it out. I will put the links in the description. So the special rule of pointing digits, is that whenever you put a digit in such a cell, this digit is repeated somewhere in the direction of the arrows as many cells as the digit itself. So for example, this could be a 2, which would be repeated 2 cells away. And note that this does not prevent the digit from being repeated somewhere else on the diagonal. And moreover, the fact that a cell does not have an arrow does not prevent it from having the same property. For example, I could have a 3 here, which would work with an arrow in this cell and an arrow in this cell pointing towards each other, but there is no negative rule in this puzzle, so we can only focus on the positive property. Whenever you have an arrow, look at what you can deduce from that. And I solved the puzzle in 30 minutes and something like this when I test solved it for Akash, because there was a tricky classic Sudoku step in the end of the puzzle. So I hope I will find it again when we come to this point. So let's start with those arrows here. This one here points to one of those 2 digits, and it won't ever point to the same digit in the same block. So this will be repeated here, and it can only be a 2. This could be a 1 repeated here. It wouldn't be a 2. It could be a 3 repeated there. So this is 1, all 3. This won't be a 1. It won't be repeated in the same box. It won't be a 2 because of Sudoku. It could be a 3. It couldn't be a 4 because there's already a 1 in this cell. So that's a 3 repeated here. And this is finally a 1 repeated here. So this will have to be at least 4. 1, 2, 3, 4. It could be a 4 repeated into this cell or a 5 repeated here. Let's move on to those. So by the same logic as this one, this can't be a 1, it has to be a 2. This could be a 1, it couldn't be a 2, and it couldn't be a 3 because of that. So that's a 1. This won't be a 3 or a 1 or a 2, so it won't repeat it. It won't repeat in any of those cells, and that's the 4. This couldn't be any of those. 1, 2, 3. It can't be a 3, 4, 5. It will have to be a 5 repeated here. Nice. This seems to be quite constrained. It's not a 1 or a 2. It won't be a 3. It would have to be repeated here. It won't be a 4. It can only be a 5 repeated here. What about this one, which is similar, or this one? This one is similar. Not 1, 2, 3, 4. 1, 2, 3, 4, 5. It can only be a 5 by the same type of arguments. And this one can still be a 4 here or a 5 there. And actually, because of those digits, this has to be a 5. But we're not sure that this is the 5 repeated here. It could still be the 4 repeated there. What about this? It can't be 1, 2, 3, 5. 1, 2, 3. It can't be 4 because of that. 5, 6. It can only be the 6 repeated here. What about this? It couldn't be the 1 repeated here. It's not the 2. 1, 2, 3. 3 is not available. 4 works. 5 and 6 don't work. So that's the 4 repeated here. And finally, this is the 5 that is already repeated there. And we're left with those 2 clues. So this can't be any of those digits. It can still be the 3. It can't be the 4. So 3 is a possibility here. 4, 5 doesn't work. 6 doesn't work. 7 and 8 work. This here won't be 1 or 2. It won't be 3. It won't be 4. It won't be 5. It won't be 6 here because of that. 7 and work. 7 and 8 still work. So we still have to disambiguate those 2 clues. Well, actually, with Sudoku, we know that this is a 3, which is repeated here. So we're left only with this one. And let's do some Sudoku. Those 3's place a 3 here. There's a 3 somewhere there. What about the 1s? Yes, 1 goes there. Somewhere in here. So I probably have to place a number of pencil marks to make some progress, but first I can place the 2 here. There will have to be a 2 somewhere. I can't do anything more with the 2's, but with the 4's I can place a 4 here. 3 goes there. Don't see anything with the 4's. There will be a 1 somewhere in here. Somewhere in here. So it's probably time for some pencil marking. Well, not sure where to start. This 7 is somewhere here, so those are from 4, 6, and 9. And that's not the 4. 4, so 6, 7, or 9. 4, 7, or 9. On this row, I still need 1, 6, 8, 9. So 1, 6, 9 here, right? This row still needs 2, 7, 8, 9. This needs 4, 7, 8, 9. So this is from 7, 8, 9. There's a 6 somewhere in here, but that doesn't help me that much. 4, 7, 8, 9 here. I feel like I'm missing something. Not sure what. This column still needs 2, 6, 7, 9. I hope I used all those clues correctly. Oh, the 5. There's a 5 in the middle. This is what I've been missing. With all those fives, I can place a 5 here, which disambiguates the ones. This cell now contains 8 or 9, and those contain 7, 8 or 9. And with this one, so that was the last 5 in the grid. So you can see I should make more videos, definitely, because I'm losing my steam. I'm saying that this will never be an 8 because of this. If this is 7, then 7 goes here, and this is not 8. If this is 8, then 8 goes here. So this is not 8 in any of those cases, which is quite interesting. And likewise, this can never be a 7. I'm not sure that this is so useful, but this is a really nice logic, so I thought I would mention it. I still need a 7 in there. 6, 7, 8, 9. Not so interesting to pencil mark. What am I missing? Oh, this one, I forgot. I forgot to place it since the beginning. Oh, so now this was never an 8 in the first place, so that's a 7. And this 7 is repeated here. Sorry about this. I lost quite some time missing this easy deduction. So this is not 8 or 9, that's a 2, that's a 7. And with those 7s, 7 goes there. That's not here. Those are from 6, 8, 9. Now this row needs a 4 and a 7, so that's 4. That's 7. Those are from 4, 8, 9. 7 is not here. So this row still needs a 7. It has to be here. Those are 3 and 6. There's a 3 here. 4, 8, 9 here. This is 8 or 9. Those are from 3, 8, and 9. I don't think I can locate the 3 in here. Those are from 6, 8, 9. This column needs the 7. This is from 6, 8, 9. 2 is not here, so 2 in the box is there, so that's the 9. That's the 6. This row needs the 2. It's here. This is from 3 and 8. Those are from 3, 6, 8. So 6 or 8 here. 3, 6, 8. That's not a 4. And actually 7 goes there on this row. On this row 6 is here, so this is from 4 and 9. And this is from 6, 8, and 9. And this must be the place where I need to find some classic Sudoku advanced technique. So if I focus on digit 6, I don't think I can do anything with digit 6. Likewise, 3 is just that. And I could use uniqueness to remove 8 from those cells, but I won't do that. I want to solve it logically. So 3 and 6 don't give me anything. 4 is not constrained either. So 8 and 9 are the key digits. So where should I look? What am I looking for? I'm seeing those. I could be looking for W, how's it called? W wing. I'm not finding this. Well, this looked promising, but it doesn't give me anything. Is it the positions of nines? This looks like the start of some interesting configuration. Perhaps 8. Just looking at 8s. Well, that doesn't look so promising. Perhaps 9s. This really looks interesting. Perhaps this. Oh, well, this looks somewhat tricky. Perhaps on the rows. Or perhaps I'm just missing easier eliminations. I missed easy eliminations in the latter part of the solve. No, I don't think I can do anything with those. So this could look promising, like the start of some swordfish. So let's just pinpoint all 8s. Oh yes, this looks promising with the 8s. Is there anything else that would interact? Oh yes. All right. So 8s in this column are here. 8s in this column are there. And then in this column, 8s are here. And that's a finned swordfish. So what is happening here? Well, first thing, on this row, you will agree that 8 can't be in both those cells. So if 8 is not here, then 8 is here. So if 8 is not here, then 8 is here. And in the other scenario, 8 is not here, in which case 8 is here. So we know that at least one of those two cells contain an 8. And what I'm seeing is that in the case where 8 is here, because it's not here in this column, 8 will have to be in one of those two cells. So first case, 8 is in here, in which case 8 goes there. And we say that 8 has to be in at least one of the yellow cells. So first scenario, 8 is here. Second scenario, 8 is here. So 8 can't be in any cell that sees both red here and this cell here. So 8 can't be in this cell. So that's quite a difficult elimination, but it's one elimination nonetheless. And now there's some restriction on 8, or perhaps on 9, but where else can we look for eliminations on 8s? Let's just color all cells with 8s. And let's see if I find another interesting configuration. This one looks promising. Perhaps it's on the rows. This row and this row look promising. Oh yes, this works. No, actually it doesn't work. I had missed this one. So perhaps well, how can I use this? Oh, sorry, I've been missing the fact that there is an 8 in here. So I can just remove the 8 here. Now, perhaps this row. Yes, oh yes, that's the point. Now I can do the same kind of logic with 8s on this row and 8s on this row. And this is a standard skyscraper or sashimi X-wing. So let's remove all instances of 8s. What is happening is that in this column, 8 can't be in both those cells. So if 8 is not here, then 8 will be here. If 8 is not here, then 8 will be here, which means that 8 is at least in one of those two cells, and therefore 8 can't be in this cell. Another way of saying this is that if 8 were in this cell, then 8 would be in both green cells here, which would prevent 8 from being in any of those two cells, and this would break column 2. So I can remove 8 from this cell, which gives us the 9, and from this point on, it should solve 9, 8. So now this is a 6, and this is 8, and those are not 8s. This is not 9 anymore. Well, is it finished? I'm not sure that this is finished yet. Oh, this 6 gives the 9 here, so 8 and 6 and 9 and 6. And this is 9, which gives 4, 9, 4, 8, 9, 6 and 4, and 8 and 6 and 3 and 8 and 3, and 8 and 9. So this was the key point to finish the solve, which means that in the end, the main difficulty in this puzzle was the classic Sudoku part, but I really like the interactions between the cells, just the way we could use the arrows in the first place to start the puzzle. Well, so this was a showcase of one of the 120 puzzles in Akash Doulani's Sudoku Exotica Volume 2, which you can order in any one of the links that I will put in the description. Thanks for watching this video. See you someday in SudoKanard on SudoKanard.